I can't believe that radioactive substances, wintergreen mints, the northern lights, and sticky notes have something to do with each other. Hello and welcome to the Science Factory's YouTube channel. I'm your host, Mr. Brian, and today we're going to be investigating a phenomena that you've probably never heard of. I've decided to dub it the sticky note flash. So I keep a pad of sticky notes next to my bed in case I have ideas during the night and I want to jot them down so I can get back to bed. And recently, I noticed that when I peel off the Post-its in the middle of the night, there's a weird blue flash. And at first, I thought my eyes were just playing tricks on me. But after this happened a few times, I decided to start looking into it, and wow! I thought it would be a quick and easy explanation, but it turned out to be way cooler than I ever imagined. So, I got curious the next morning. What is going on? How could sticky notes create light? Now, a big clue is that this only happens once. If you peel a sticky note off of a pad, and then you put it back together, it won't happen a second time. I found out that what's happening is an optical phenomenon known as triboluminescence. In this phenomenon, light is generated when certain materials are peeled apart, scratched, rubbed, or crushed. The word triboluminescence comes from the Greek word tribin, which means to rub, I'm probably mispronouncing that, and the Latin word lumen, which means light. It turns out that Band-Aids also give off this blue light glow, which helped me narrow down what exactly is happening. It was also noted by 17th century philosopher Kevin Bacon that when you crush sugar crystals, blue light is given off. And it turns out that quartz and other minerals can exhibit this phenomenon as well. Have you ever heard of the wintergreen mint flash? Even that is an example of triboluminescence. But why does it happen? Well, the phenomena is not fully understood yet by scientists, but we think that it's caused by the rapid disruption of static electric charges. The static electric charge between two molecules is known as the van der Waals force, and it's a very weak force that attracts molecules to each other. It's actually the same force that allows plastic grocery bags to be able to stretch when you pull them apart slowly. We'll do a video about that soon as well, and when I upload it, I'll put the card up here. It turns out that when some adhesives get pulled apart, or when certain minerals like sugar get crushed, the electrons within those materials can become excited. And when electrons jump between orbitals, or the electron shells around an atom, they give off photons. The photons that are given off in this case are mostly not visible because they're too high energy for humans to see. But the photons that we can't see are so high energy that they can excite the nitrogen atoms in the air around the material. And the nitrogen atoms can then convert that light into a lower wavelength, blue light. And so, because the nitrogen atoms get excited, we're able to see this blue flash as the nitrogen atoms convert the high energy photons into lower energy photons. It sounds to me like this is the same thing as ionized air glow, which is why certain radioactive materials glow, and also how the aurora borealis or northern lights work. Unfortunately, I wasn't able to fully confirm this, so I would love if you know more if you could comment down below. Let's figure this thing out together. In any case, it's not a very bright phenomenon, so as cool as it is, if you want to try it at home, make sure that you're in a dark room and that your eyes are adjusted so that you can see the phenomenon at night. Well, there you have it. Sticky notes create light in the dark. Who knew? I can't believe that radioactive substances, wintergreen mints, the northern lights, and sticky notes have something to do with each other. This is just another example to me of how science can make really boring things interesting. I mean, I'm not usually fascinated by sticky notes, but now I can't stop researching about them. Now, one more thing that I found about this that was really fascinating is that researchers at UCLA set up a roll of Scotch tape in a vacuum and pulled the tape all the way off of the roll. What's significant about this experiment is that there's no nitrogen atoms to absorb the high energy photons and re-emit them at a lower wavelength. In other words, researchers are able to measure the radiation that's given off during this experiment because there's no air in the chamber. And what they found is that if you unpeel an entire roll of Scotch tape in a vacuum, it emits enough photons in the X-ray wavelength to X-ray a human finger. Good thing that we have nitrogen in the air to protect us from all of those pesky Post-it notes and rolls of tape. This definitely gives me pause about chewing sugar in my mouth. Maybe we should pre-crush our sugar from now on? Well, that's all we've got for today. As always, my name is Mr. Brian, and I hope that we see you again soon for another video. If you like this video, please make sure to leave us a like and subscribe to the channel and click all notifications to help support us. Until next time, take care. Why is research on photons so easy to understand? Because it's a light subject. A photon was checking into a hotel, and when asked if he needed any help with his bags, he said, "No thanks, I'm traveling light."